So number 5, got the picture started, 12 feet cubed per minute. So what is that in terms of the variables of this problem? Nobody wants to talk. Well, we know it's a rate, so it's a derivative. We have volume over time, so that's how the volume is changing. So dV dt, 12 feet cubed per minute. That's as the sand is being added. It's positive because we're adding sand to the pile. Again, if you don't think about positives and negatives, if it's positive, you'll be fine, but if something was decreasing, then you better make sure it's negative. Whose altitude, the altitude is just the height, whose altitude is 2/3 of the radius. How fast is the height of the pile increasing? So we want to find dH dt when the radius is 6. Okay, so you can go back and reread, make sure we got everything. Sand is poured on the ground at 12 feet cubed per minute. Got that. Forms a conical pile. Yep. Altitude is 2/3 the radius. Find dH dt when the radius is 6. Okay. Drawn and translated. We're good on that first 2. And by the way, when I go to grade, they're going to be, 10 points a piece or so, these free response ones. So I'll probably use this as sort of the rubric for grading them. If you draw it, that's worth 2. If you translate it, that's worth 2. If you pick the right equation, that's worth 2. And so you can get a lot of the problem right even before you get to derive and plugging numbers in and actually getting the right answer. So follow this path. That'll get you points even if you can't quite make sense of the whole problem. All right, volume of a cone, which we would give you if you need it. Which I already told you will need it. So volume of a cone is 1/3 pi r squared h. Accept that. Well, not accept that. That's fine. That's accurate. If I take a derivative now, what rule am I going to have to use? Product rule. And I'll get a dr dt somewhere and a dH dt somewhere. I really don't want to do that. So this equation piece, sometimes it's helpful to make a variable go away to make your calculus easier. So pay the price in terms of algebra to make your derivative a little bit easier. Well, we know that this is true. So let's be careful here. If I replace h, then I have things in terms of r, which I guess is okay, except that I don't really want to know things in terms of r. I want to know things in terms of h. So let's rearrange this. R is 3/2 h. And then in place of r, we'll put 3/2 h. Then our equation will only have h's in it. And it'll make the derive step a whole lot easier. So I'm still on the equation step. I have not started to derive yet. 3 squared is 9, 2 squared is 4. H cubed. And again, I don't really have to clean that up, but a derivative is coming, so I think I may as well clean it up a little bit. 9/3 is 3, so 3 pi over 4 h cubed. I still haven't done any deriving yet. That was still all equation. And again, the motivation was I was going to have to use product rule, and when I did that, I'd get 2 related rates on the right-hand side, R and H. Now that I paid a little bit of an algebra price, my derivative is going to be a lot nicer. This is just the power rule. 9 pi over 4 h squared. Why is that not right yet? What's missing? dh dt. Okay, so I derived. Now I can worry about substituting. Let's see. I like to circle or box what I'm looking for. And then I better have everything else so that when I substitute in, I can find this stuff. Oh, I boxed the wrong thing. Because I know dv dt, I'm looking for dh dt. Which means I better know h. And I don't know h directly, but I know r is 6, and h is 2/3 of r. So h is 12 divided by 3 is 4. So I do know h after all. So now comes the substitution. So dv dt is 12. 9 pi over 4. H is 4. dh dt. Now, the only thing left is algebra, but I'm not done. This isn't a safe stop because I haven't solved for dh dt yet. So how much I want to do as cleanup is kind of up to you, but I definitely need to get dh dt by itself. So 4 squared over 4 is 4. Times 9 is 36. So 36 pi dh dt. Which means dh dt is, here, I'll be lazy here. I'll just leave it as 12 over 36 pi. Reduce it if you want. Leave it if you want. Doesn't matter. I do need to put units on there, though. I did not keep up with units as I did the problem because I knew that at the end I could get units from h is in feet, and time in this problem is in minutes, so feet per minute. So most people handle units that way. I mean, you can do it the official way where you plug in everything and keep up with feet and minutes and canceling, but it's usually easier to just grab it at the end. But make sure you include it. Answer is posted at the bottom. The answer posted says 1 over 3 pi feet per minute. Yeah, that's the same thing. So I got it one right. Questions on that one?